This is my fourth year at iOSDevCamp and third year on stage. I'm super excited every year. I see familiar faces, I see new faces, and every time I come here, I learn a lot of new things and get inspired, and it's an amazing experience. Today, I want to look at where the most popular cross-platform mobile frameworks are in terms of enterprise scale app development. And what I mean by that is, it's one scenario when you're a small team who's starting mobile development from scratch. You have so many options. You can build natively. You can choose any one of the new cross-platform mobile frameworks. But in enterprise scale like ours, we've been working on our flagship app over 4 years. We have more than 50 people maintaining the code, making changes on any given day. And we have 4 years of battle-tested core libraries, networking, security, persistence, that we just can't throw away. And because we're a bank, there are lots of regulations. Not only do we have access to sensitive customer information, but we're moving money. So the stakes are much higher when it comes to things like security. So the criteria are much different. And I want to today look at these frameworks and see if they achieve enterprise goals of shipping on time and securely, delivering great customer experiences, and also see if they can keep developers happy. So today's agenda, I'll give an overview of these 4 frameworks that are the most popular, the most promising. And I want to take a moment and talk about why there's even a need for a cross-platform solution. And according to the last estimates, there are over 2 billion mobile devices in the world, and more than 99% of them run iOS or Android. As developers, we want to target the largest population, so we built on iOS and Android, which means we need to learn 2 platforms, and each platform has their options of programming languages. So we have Objective-C, Java, Kotlin, depending on what you like. And now we need to have 2 teams building features, possibly platform teams, infrastructure teams. And it's a challenge aligning feature release dates. And it's also difficult to deliver great user experiences one time, and quite more challenging repeating that on multiple platforms. So this is where Xamarin, Flutter, React Native, and Kotlin Native come into the scenario. And the promise is that the developers only need to learn one platform, one programming language. They can ship and deploy to multiple operating systems and devices. And they can deliver the same user experience on both platforms. So let's look at what these are, how they work, compare and contrast them with a focus on enterprise app development. So I talked a little bit about enterprise scale app development, and some of our evaluation criteria is maybe different than an average app. In terms of maturity, for example, we care that the platform is going to be there. We cannot just port everything if, say, we were developing on Flutter and Google decides that they'll no longer support it. In terms of developer workflow, we want to look at how naturally the development tools will integrate with our existing toolchain, how these features will integrate with our existing apps. In terms of performance, of course, we want native look and feel and smooth scrolling and reasonable CPU memory usage. And we want to make sure our stance on security is not weakened and that the apps we develop in these platforms are testable, and they allow us to support a wide range of population. So I want to start off with Xamarin, which is an open source technology owned by Microsoft that lets you develop mobile apps using C# and ship in iOS and Android, as well as actually on Windows Phone and Windows desktops. The company was founded by the same people who built the GNOME Linux desktop environment. And around 2012, they had the idea, now that they were able to port the .NET SDKs and environment to Linux, they wanted to do the same with iOS and Android. So they released Xamarin for Mac, and the Visual Studio integration happened in 2013. With their technology, you were able to build an iOS or Android app using C# in Visual Studio. And they came up with a cross-platform set of UI components called Xamarin Forms that let you build an app, and it would ship in iOS and Android at the same time. This was through embedding what's called extensible application markup language inside your C# code, and they built cross-platform UI components. So if you did not care too much about custom UIs, but a lot of your app was more business logic and forms and processing, that was perfect. In 2016, they got acquired by Microsoft, and their SDK was open sourced. Unfortunately, in 2017, Microsoft announced that they would no longer support the Windows Phone. However, they were investing heavily in the Azure cloud SDKs, and still, they were supporting Xamarin. And the way Xamarin works is through C#, you can call iOS and Android SDKs through bindings, which means somebody has to create those bindings. Whenever there's a new version of iOS or Android, the Xamarin team at Microsoft releases a new version of Visual Studio that has these bindings, and they have been pretty on time. Like whenever there's a new Xcode version, the next day there's a new Visual Studio for Mac version. And they have a terrific cloud support. They have something called Mobile Center, and you can build your CI/CD pipeline and deploy it to devices. As you may know, Hockey app is owned by Microsoft. They have something called Test Lab, so you can test UI and unit test in actual devices, and you'll see screenshots and videos of your results, which is amazing. So Xamarin apps look something like this. You have Visual Studio for Mac, and I don't know if you can see the text, but you have access to all the iOS SDKs, and this is a view controller in C#. And this app uses the Vision and CoreML SDKs on iOS and runs on iOS. What we're interested in more is the cross-platform side of it. So this app could not be deployed on Android because it's using iOS-specific SDKs, but if you were using Xamarin Forms, you'd be able to deploy an app that you built on Android as well. I think there's value in looking at how these frameworks operate. A little bit of idea about the architecture will give us insight into how they achieve native performance. And they all go about this in slightly different ways. So Xamarin apps run with the mono runtime next to Objective-C runtime. And the C# code gets ahead of time compiled into native instructions. And through bindings, you're able to call iOS APIs. And similarly on Android through Java native interface, the just-in-time compiled code calls into Android APIs, and you're able to display native UI components. What's great about Xamarin is you have access to all the .NET APIs available out there, and you can use all iOS or Android frameworks in your apps if you're building for iOS or Android separately. But you cannot integrate Xamarin into an existing iOS or Android app. And going back to our enterprise evaluation criteria, interoperability with an existing app is a must. So unfortunately, I'll short circuit our Xamarin conversation here, but still it's an honorable mention, great framework, and I highly recommend you check it out if you're building an app from scratch. So next up is Kotlin, and I have here a map of Scandinavia because it's named after an island near St. Petersburg. So the team behind Kotlin, JetBrains, is based in St. Petersburg, and they got an inspiration to name the language, just like Java is named after an island in Indonesia. It was built to replace Java on Android because, first of all, a lot of Android developers agree that Java has a lot of boilerplate code. So on average, with Kotlin, you write 40% less code. And it has a lot of modern features, and the syntax is not that unfamiliar to Swift developers. The language has supports for features such as optionals and generics, extensions, and operator overloading, and many more. And the beautiful part about Kotlin is it's interoperable with existing Java code, and it's backward compatible. So like any version of Kotlin code that you write will compile with any future versions or older versions of JVM on Android. But we're not interested in Android development, so I'll get to why Kotlin is up there in our slides. So just a little bit of history. It was unveiled in 2011 and open sourced the year later. And around 2016, version 1 was released. And as far as I know, among the Fortune 500 companies, Capital One is one of the first to adopt Kotlin in a production app. Back in 2015-16, we had an app called Level Money that used Kotlin, and we have a quite passionate group of Kotlin developers. So last year, Google at the I/O conference announced first-class support for it, and popularity of the language skyrocketed. So look here at the adoption graph, and on GitHub, beginning of 2017, there were 5 million lines of code written on Kotlin, and in less than a year, it's over 25 million. And there's also a survey of most loved languages, and Kotlin trends at number 2. In relation, Swift is trending around number 6. What's interesting for our talk is an announcement they made last year. So in November, they had the first Kotlin Conf conference back in San Francisco. And they announced that you'd be able to use Kotlin to write backend code. You'd be able to write web applications. You'd be able to write iOS applications. And this was huge, and everybody celebrated and were curious about it. So that technology is called Kotlin Native, and we're going to talk about it in just a second. One thing that our passionate Kotlin developers can't stop talking about is how easy it is to onboard to Kotlin. First of all, because we know Swift, the syntax will be familiar. There's this website I highly recommend you checking out called Kotlin Clones, and it'll let you go through all the fundamentals and basics. You have to write simple functions, and you're trying to pass test cases, and at the end of it, you're sort of a competent Kotlin developer. And it takes maybe 1 or 2 days. We had a couple of teams who onboarded using this, and they were very happy and loved the language afterwards. And at the end of it, you get this fun tweet. So Kotlin Native is primarily designed to allow compilation for platforms where virtual machines are not desirable, such as embedded systems or platforms like iOS. And it compiles your code ahead of time into the native machine instructions. And there are a couple of ways you can go about building an app or a framework using Kotlin Native. One of them is through AppCode. So AppCode is JetBrains' popular IDE, and some people swear by it. Anybody using AppCode here instead of Xcode? Great, one person. So in March, they announced and released a plugin that integrated Kotlin into AppCode. Now you can write an iOS app using Kotlin. So as you can see here, we have a view controller that's extending UI view controller, but it's all Kotlin. But we're not really interested in just writing iOS apps. The focus here today is cross-platform. So let's look at what you can do with AppCode using Kotlin Native. So Kotlin Native, the SDK, you can go to GitHub today. It's open sourced. Download it and build it yourself. Or use the plugin in AppCode. And instead of creating a new app, there was another selection to create a framework. So once you select that, you can write Kotlin code. And in your build file, build.gradle file, as you can see, there are targets, the 4th line from the bottom. And I have specified iPhone and iPhone simulator, but you can also mention Android and Linux and Mac OS. And your code then will get compiled into those targets. And I'll have a framework once I build this. Okay, so I have a simple Kotlin class here adding 2 integers. Once I build it, I'll have 2 folders, and they will have .framework files for iPhone and the simulator. And once I look into the headers inside these frameworks, as you can see, my Kotlin code has been converted to Objective-C, and I can integrate it into an existing iOS app. And once I import it, I have code completion and use it any way I want. There's a catch, though. So the any way I want part is only the intersection set of what's available to iOS and Android, and there's not much, actually. It's the standard library that Kotlin ships with. So what could this be? It's the sort of maybe business logic, maybe potentially your networking code and model layers, but anything UI related, you'd need to branch into the iOS and Android SDKs, which would make it not cross-platform. So other than that, in terms of performance, because it got compiled into native instructions, it is just as fast as your Objective-C or Swift code. So next up, I want to talk about a very popular cross-platform framework called Flutter. It's an open source mobile app SDK that was developed by Google, and it gives developers an easy way to develop great user experiences and iterate quite fast on it. It was unveiled in 2015. And until last year, it was an alpha, but they mentioned it as production ready. And what makes it so popular is a number of things. First of all, you can call into Objective-C or Swift from your Flutter apps. And there's a feature called hot reloading, which allows you to change your code, and your changes are updated in your simulator without you having to recompile or relaunch your app. And there is a built-in plethora of widgets, material design and iOS design, and they call it Cupertino. And out of the box, you can build beautiful, beautiful apps with great animations without knowing much about mobile development. And you can use Android Studio, IntelliJ, or Visual Studio Code. And here, I want to show you a gallery app. So out of the box, once you install Flutter, this is an example app that has 4 apps inside it. One recipe browser, another shopping app, an address book, and another app that showcases various animation capabilities. And on the left is the iOS version, and on the right is the Android version. And what's remarkable about it is that they look and behave exactly the same, and they're very performant. And it's a perfect cookbook of code samples, and you can pretty much, looking at these apps, build a lot of the apps that you can think of. Flutter is developed using the Dart language, which was developed by Google and open sourced in 2012. And it's an ECMA standard right now. It's a modern language, has C syntax. And when it was unveiled, a lot of people did not see much use for it. So it was not really popular. And there are a couple of ways to run your Dart code. And I prepared this Dart path. So you can go to that URL at the bottom and look at some examples. It can be compiled as JavaScript and executed in browsers. The Dart SDK also ships with the Dartium browser, so you can run Dart code in that browser directly. It also ships with the standalone Dart virtual machine, and you can run your apps there. Or in the case with Flutter, it can be ahead of time compiled into native instructions and can run on the specific platform. So again, we looked at Xamarin architecture and how it achieves native performance. It's interesting to contrast how Flutter does it, because they take a quite different approach. So here you see 2 portions, but logically there are 3 layers to their architecture. At the bottom, there is a C++ engine. This Skya on the left is actually the rendering engine used in the Chrome browser. And it's heavily optimized for 2D rendering on mobile devices. And in the middle layer, there is the foundation layer. It's a reactive layer that takes care of things like event handling and animations and gestures. And at the top is the widget library, all the like Material and Cupertino, out-of-the-box navigation widgets and UI components that'll help you build most of the apps that you can think of. So the interesting thing about Flutter is it's very much like a game engine in that here in the view debugger, you'll only see a 2D flat view, even though we have a bunch of images and text and labels and a navigation controller and another view controller, because everything is happening in the Dart context, and it's rendering things inside the UI view. So you will not be able to, for example, modify the layout of your Dart objects from iOS context. Everything is happening inside their own rendering engine. Let's see. Previously, we ran extensive benchmarks on these cross-platform frameworks with a focus on performance and looked at their runtime memory usage, GPU, CPU performance, and it no longer is such an interesting thing because all of these frameworks now have native performances. But one thing that I want to note is they still increase your binary size a little bit. So here at the top is our benchmark results from 2017. As you can see, the app size increased a little bit. At the same time, the structure of the frameworks, it has, for example, Flutter.framework and app.framework. Their sizes changed, the assets moved around, and there are new things added. And it's a quite fast evolving architecture and framework. So these things will happen. At the same time, one disclaimer is when compiling Dart, we did not optimize it for size, and we did not strip libraries that were not used in the app. So your mileage will vary. Let's see. I'm trying to go to the next slide. OK, let's take a second to look at the widgets. And this is supposed to be a video. Well, the video is not playing, but I'll tell you. So, OK. Out of the box, you have dozens and dozens of UI components in the material library. And these are things such as buttons and labels, but also things like tab bar controllers and whole like drawers and menus and forms, which on iOS maybe would take a lot of time and effort to recreate. So out of the box, if you want to build an app that looked like material design, it comes for free, which is amazing. And widgets also are an important construct in Flutter because unlike, say, iOS or Android, where we have model and view and controller and all these like different layers, and we can organize our logic in different objects, in Flutter, everything is a widget. Even your root view controller is a widget, and you have children widgets, and each widget then inherits properties and styles from your parent. And once you want to update something about how you render, you update the state, and that widget is recreated. So, OK, so here's actually the video of some of the out-of-the-box widgets. And you can really build beautiful-looking apps with great animations, and these are out of the box. You don't need to even customize anything, as long as you like material design. So now that we know how you can construct UIs, let's take a little bit of time and talk about layout, because this is also going to be a theme repeating in React Native. Flutter uses the CSS-style flexbox for layout, which means objects are aligned through a main axis, and they will expand to fill available space. So in different screen sizes or devices, you won't need to worry about it. Just like a web page, the rendering engine will take care of it. Here we have 3 widgets that are aligned in a row, and here they're aligned in a column. And the axis alignment, you can align it so that they're at the start of the axis in relation to their parent, at the end, in the center, and you can have spaces around in between. And there's also relative sizing of your widgets. Here we have a row of 3 widgets, and their relative width is 1. And now we have 3 columns. And if we wanted to make one of them twice as tall as the other, we just specify the flex ratio, and just like that. Some of the developers that I talked to recommended this website called flexboxfroggy.com. It is a 24-level game that teaches you the basics of Flexbox and takes maybe half an hour to complete. Your goal is to try to align the frogs in the right colored lilies. And it's a very fun game, after which you're onboarded to play out in Flutter and React Native. So now that that's out of the way, let's look at how we can populate our UI components with data we download from the network. And making network requests is very straightforward. First, on the left, we have the response from a JSON request, and on the right is a custom Dart class that maps to it and populates it from a JSON result. And there's a popular Dart package called HTTP that's used to make network requests. And for those of you who are familiar with features, we'll have an easy time. The way features work is whenever there is an operation such as reading something from disk or getting something over the wire, you don't want to block the main thread, and by marking that operation as async, you're dispatching it to a background thread or a queue to be executed at a later time, and immediately you return the future object, and you cannot access the properties of the future object until that request completes. And once it does, you get a message, and you either register a callback, and registering callbacks could be sort of involved, and your code can get nested. So instead, you can use the async await expressions, which lets you write asynchronous code like you were writing synchronous code, but it functions just like the async counterpart. And because network requests are so common, there's a Flutter out-of-the-box widget that works with future objects. Here, we're seeing an example of it. It's called Future Builder. It takes as parameters a function that returns a future object, and when there's a result, it does something with it. By default, it's displaying a progress indicator. And using this function, we can build a screen that looks like this, 4 widgets that are aligned in a column. And the second from the top displays title over the network, and at the bottom, the body section of the JSON is displayed over the network. So this is all fine and good. When you're building screens, we know widgets, we can lay them out, we can make network requests. But what happens when you need to do something specific to the platform, like access the sensors, use the camera, or do something specific with an iOS API? And Flutter does that through platform channels. So you have the Dart context and you have the iOS context. And your Dart context does not have a reference to the view controller, and vice versa. Whenever you want to exchange information, call functions, you do it through what's called platform channels. And the functions and parameters and results are serialized and deserialized over a bridge. So this is how it would look in code. On the left is the Dart counterpart. We're creating a message channel. The names need to match on iOS on the right and Dart on the left. And we register a callback function, and we can call the send method and pass primitive data types, also data structures like dictionaries, arrays that contain these primitive data types. So there's a little bit of serialization that happens on your end. And integration with existing apps, of course, is the enterprise evaluation criteria. And I'll start off by saying it's not clean or easy, but it is possible. And there is sparse documentation around it. So there was lots of trial and error getting this to work. I'll quickly go through the steps, but it involves creating a Flutter app inside your iOS project and copying resources and config files andplists over and building them inside the Flutter project and then embedding it inside your iOS project. It's definitely something that can be streamlined more before it's maybe ready for enterprise use, but you can then launch your Flutter view controller inside your iOS app, and here's actually a sample app that passes messages between the Dart context and the iOS context. On top, when you press the button, the iOS context receives a message and vice versa. So that's pretty much our overview of Flutter. And last but not least, we're gonna take a look at React Native, which has been around for a little longer. And this is Facebook's platform using JavaScript to deliver both web apps and iOS apps and Android apps. And it's got an interesting history in that around 2010, Facebook invested heavily in hybrid apps. And they wanted to build a web app and iPad app and iPhone app using HTML5 and iOS and Android. And in 2012, Mark Zuckerberg notoriously was quoted saying in TechCrunch Disrupt that their biggest mistake that far was investing too much on HTML5. A group of engineers at Facebook took that feedback to heart, and in a hackathon, they developed the first version of React, which allowed dynamically updating web pages using JavaScript and embedding HTML inside it. And there was a lot of promise in React, and another group in parallel started implementing React Native, which is building native components, native UIs using JavaScript, embedding XAML, XML application markup language, the same syntax that Xamarin Forms use, actually. And internally, they started integrating it inside their newsfeed and ads manager. They integrated it into Instagram app, and in 2015, it was open sourced. There was some contention around the licensing. It was some sort of a variation of a BSD license, and big companies did not really like that, so it was relicensed last year. And just a couple of weeks ago, on their engineering blog, they mentioned they're rewriting their architecture, and I'll talk about what that means in a second. But why React Native is so popular is for similar reasons to Flutter. It offers hot reloading, so prototyping is very easy. You change your code, and immediately your UI is updated. No need to recompile, relaunch your app. Different from Flutter or Kotlin Native, one thing you can do is you can update your code remotely. So React Native apps, while they're running, they run with a thin HTTP server. Currently, it's called Metro Bundler. And your JavaScript code and images is served through that server. And that's actually the mechanism that helps hot reloading and also remote debugging, which we'll look at in a minute. And you can update that URL to be something remote so that you can publish a new version of your app or change something about your app bypassing Google Play or the App Store. In terms of its architecture, at the top is how you would display text in React. You're embedding HTML tags inside your JavaScript code, and at the bottom is React Native. It's very similar, except instead of HTML, you're inserting XAML tags. And the engine is the same, but there's a C++ bridge that takes that code and translates it into the native UI counterparts. So on iOS, this would correspond to a UI label. On Android, it would be a text view. And I like talking about the architecture because it'll help us better understand and contrast these technologies. There are 3 layers. At the top is your native iOS stack. At the bottom is the JavaScript stack. And in the middle is the C++ bridge. So your user events are generated on the native layer, and then they are serialized into JSON packages, function names, function IDs. All that is asynchronously passed to the JavaScript layer, where those are deserialized and then processed. And the responses are serialized, batched, packaged, and sent back up to the native layer, as a result of which UI is updated or whatever business logic needs to happen is happening. And the major architecture rewrite that I mentioned a couple of slides ago is because of this architecture. So 3 weeks ago, they announced that this architecture has worked well for most apps in the last few years. But because of the asynchronous nature of this message passing system, they're not able to access some native APIs that require synchronous communication. And because of the batch nature, there's a little bit of redundant overhead. So they want to move to synchronous and asynchronous optionally message passing. And instead of serializing things into JSON, they want to access shared memory. And under the covers, they mentioned they're rewriting the whole architecture, but they say there won't be a lot of changes on the UI layer. But like when you hear things like that, think about the maturity and interoperability types of things. And as an enterprise, these are sort of like a little nerve-wracking, to say the least. In terms of how rendering happens, it's quite different than Flutter. As you can see, here we have a long list view of images and text. And in the view debugger, we can see there are UI labels and image views and a table view. So it is really translating into native UI components, unlike Flutter. And it's performant. So rendering 60 frames per second, app launch times around 200 milliseconds, very reasonable. In terms of app size, it's in the double digits. But again, React Native has a large dependency on node modules, and this app has not been optimized to strip unused libraries, so your mileage may vary, but it's something to be mindful about. In terms of building UIs, again, out of the box, there are shared components, so you can have these text and images and scroll views, and they'll render on iOS and Android the same. But the moment you want to do something custom, you have components that have the iOS or Android suffix, and those are not cross-platform. So there is definitely fewer shared components in React Native than Flutter. And layout is very similar, Flexbox, and works exactly the same, and it's very easy to learn. Network requests, because it's JavaScript, it's second nature. Interacting with JSON requests, again, similar to Flutter, there is futures and the concepts of async await. And what's different is the remote loading of JavaScript code. So there are a couple of ways you can go about this. One of them, as you can see, I put a breakpoint here, and my JavaScript bundle is being loaded from localhost. That's because every time you're running React Native, there's a thin HTTP server. So if you were to change that URL to a remote URL, you'd be able to change your JavaScript code on the fly. And of course, that might expose you to a number of security vulnerabilities, like how do you make sure there's not a man in the middle. And Microsoft, with their Azure backend services, has a service exactly for that, and it's very popular and works well. It's called Code Push. And it lets you Their plugin lets you take care of that without doing much work. It authenticates with their backend. And what's nice about it is when it's pushing a new version of your app, it's also keeping the old version. So in case of a regression or a crash or something unexpected, you can automatically roll back, which is a very cool feature. And it also adds things like analytics and crash reporting. And you can also use it as an A/B test framework. And you can determine what demographic should see what JavaScript code. And yeah, this is how your code would look while you're developing. Maybe you don't use code push. So one catch is, of course, App Store has very strict guidelines. So it clearly states that you can do this. You can change your app's functionality on the fly, but it cannot be drastically different than what it was when it was submitted to the App Store. So got to be very sensitive about the kinds of changes you would push. Otherwise, you might get banned from the App Store. Debugging is a very interesting experience. Because this is JavaScript and it's running a web server internally, you can remotely attach a debugger, such as the Chrome debugger. As you can see, I'm able to inspect the elements and see margin and padding and look at its style, change sizes of the components. And it really helps quickly iterate on a prototype. And as soon as I reload, all those changes are gone because I have not changed the source code. So you can do this via the Chrome debugger in Developer Tools or download the React Developer Tools and they have a debugger. I think that's a pretty cool experience. And in terms of interacting with platform native code, that's very straightforward to do. The easiest thing is accessing properties. And there's also, if you wanted to expose a native property to JavaScript, you need to wrap your native component in JavaScript, and there are macros to do that. But it's very straightforward and works quite well. And integrating it with existing apps is possible. And it's more straightforward than Flutter, possibly because it's been around longer. You need to install JavaScript dependencies, React and React Native dependencies, and that's quite large, actually. And then you need to install through React Native framework, through CocoaPods, and it comes with a number of other dependencies. And that's a little bit of large payload as well. But at the same time, when you're building your app, these get compressed. And because it's JavaScript, you can minify it, optimize it, strip all the libraries that you're not using. And it's not that bad, but it's still going to add to your binary size. So in this short amount of time, we had a chance to look at 4 frameworks, 3 of which have some promise. And we looked at their maturity, looked a little bit at developer workflow, how they would operate with existing iOS apps, and looked at their performance. And there are some things that can work really well. In terms of ease of learning, I think it's great. Dart, JavaScript, really familiar once you know Swift. And in terms of iteration speed, with hot reloading and out-of-the-box components, UI components, it's very easy to build prototypes that work and look great. In terms of performance, 60 frames per second and pretty reasonable app launch times. There's a little bit of maybe binary size increase. And once you use one of these frameworks, you have access to all the open source libraries developed in those languages. So there's a huge, huge world of open source libraries for JavaScript and Dart. And if you're using Kotlin Native, you also have access to Java libraries. So those are things that can really work well. That does not mean there aren't any challenges, and these are ready for prime time for enterprise use, though. A couple of challenges are platform maturity. So think about iOS and Android in its first and second year, how there wasn't copy-paste or push notifications, and you had to do things in interesting ways. So there are still, these are still frameworks in their infancy in relation to iOS. And when you look at their GitHub pages, there are hundreds and hundreds. In Flutter has, for example, close to 3,500 open issues. I got to give them credit. They respond quite quickly. Last year, in our benchmarks, we identified the memory issue, and they were able to actually resolve that in a couple of weeks, and they were very responsive. And what we have seen and heard is that there may be cases where doing something in native code is very straightforward, but it is exponentially harder in these frameworks, and you won't know where you're going to run into those edge cases. In terms of developer experience, it's a mixed bag because in terms of build times, it's great. You don't need to build for the most part. You can do hot reloading, your UI changes, and prototyping. In terms of debugging, though, you might run into some issues because now we have Dart context and iOS context, or JavaScript and iOS context. And where do you put your breakpoint? Where is happening? Where asynchronous, message passing could be a little cumbersome to troubleshoot some issues. And there are still inconsistencies across platforms. And this is for a reason that does not really get mentioned a lot. So the promise is you just need to learn one platform, one language, and you'll deploy to iOS and Android. But in reality, there are custom UI components that you want to build. There are custom sensors you want to access. So there are custom APIs on each platform that you want to access. And in order to do that, you need to know those platforms well. So now, as opposed to just knowing JavaScript or Dart, you have to know iOS real well, and on top of that, you got to go learn Dart, or you have to know Android real well and go learn JavaScript. So that's the reality, unfortunately. And a lot of the open source libraries developed for these frameworks are developed by people who are more experienced in one platform, and that's just reality. Like, most of us spend more time in one platform versus the other. And it shows in edge cases. There are like layout issues. The code and layout, everything is perfect, but it's aligned on Android, but not on iOS, and there's no immediate reason it should not. In terms of app size, in the double digits, there will be an increase. In terms of security, we have not really gone deep into that, but there's limited support for things like cert pinning. And when you think about all the dependencies you're bringing, say with React Native or Flutter, now you're accountable for the security of all the hundreds and hundreds of libraries that you're bringing into your app. And those are open source libraries that are changing and upgrading them and making sure that they're not changing or weakening your stance on security with every release is going to be your responsibility now, at least when you're building for an enterprise. In terms of crash monitoring, most of the tools that we use work well with iOS or Android. But when a crash happens, a lot of tools won't tell you if it was in the React Native, JavaScript context or Dart context versus iOS context. And what I hear is a lot of the companies end up having to invest in a custom infrastructure, and that really is something significant that needs to be thought about. And in terms of accessibility, while there are basic APIs, I've heard of many lacks in APIs, especially there's a blog post by Airbnb who recently announced they're moving away from React Native and going full native, that they mention because there were a lot of gaps, they had to fork React Native and build those APIs themselves, and then couple of weeks, months later, they had to port it back, and it was a total maintenance nightmare. So there are some things to be wary about. However, I'm very optimistic with the progress that these frameworks have come. They've come a long way, and they're definitely headed in the right direction. And I feel like we're sort of reliving the initial years of iOS and Android. And watching these platforms evolve is, I think, a very exciting experience. And they're also helping shape the general landscape. At Capital One, we're passionate about building great digital experiences to help improve people's financial lives. And I think with a healthy balance of native development and these frameworks, our efforts could be boosted. And I'm also curious about your experiences. I'm hoping that you were intrigued a little bit and maybe you go check out some or all of these frameworks and go build something great. And then do please let me know. Here is my Twitter handle. You can reach me. And I'd love to hear your experiences. So that's all I had for today. Thank you very much. That's a great question. And in terms of, I think one of the motivations for these frameworks, at least for Flutter, I can tell you Google had that pain the worst because they're maintaining and developing Android, and that environment is so fragmented, and they have dozens and dozens of apps in the App Store, and they have to maintain it also in the Play Store. So that's one reason they developed Flutter, and the approach they took, the like game engine for mobile apps, I think solves that problem. And the fact that they're using things like Flexbox for layout takes care of a lot of the like layout issues. And I've even heard their lead engineer mention that the fact that Flutter ended up being a cross-platform framework is a byproduct. They were not really even thinking about that initially. But I think these frameworks, one of the reasons these frameworks were developed is because of those pains, and they're definitely good steps towards solving that.
So if we're going to start on Android, go Flutter?
I definitely recommend checking it out, yeah. Please. You know, that's a great question. And like, I would be a little bit nervous to give this talk maybe 4 years ago, because when I heard like cross-platform and PhoneGap, I'd run in the opposite direction. But I think these are quite different in that those worries from like 2012, the Mark Zuckerberg comments about HTML5 and hybrid apps are no longer an issue with these frameworks. Like in terms of having access to native libraries, you know, the sensors and SDKs and responsiveness and performance, I think they've nailed it. And now it's just going through an evolution of maturing, because like it takes time for these frameworks to get an adoption so that you can like search Stack Overflow for your questions. And those are the kinds of like growing pains you'll have to go through. But in terms of the capabilities and performance, I think it's worth taking another look.
When we started out, you kind of skipped over Xamarin because Xamarin has issues with native code with existing code.
Correct.
If you're writing something from scratch, do you think Xamarin or Flutter is a better solution right now?
It'll depend on a couple of factors. One of them is your comfort with C# versus Dart, if you like Visual Studio versus you know, IntelliJ, Android Studio. But What I'd say is with Xamarin, if you want to build a cross-platform UI, you're stuck with forms, and it's very primitive. With Flutter, you have dozens and dozens of widgets. If you're OK with material design, it's far superior in terms of look and feel, animations, and yeah, responsiveness. So I'd recommend Flutter. Any other questions? Please.
So, like I've seen these content from here and they keep on coming and going. So one of the most important features I feel that is like they are not able to capture with the speed how the native features start coming into the world, like for iOS or Android UI. So which one do you feel out of all these is actually striking that thing and is moving forward in that direction? Yeah, as soon as new features are announced, say iOS 11 or iOS 12 or something like that, or with Android, how soon they start catching control and implementing that happens.
That's a great question. So if Xamarin was still an option, they provide like support the next day. They've automated all that. Kotlin Native, of course, you cannot do cross-platform the moment you're thinking about iOS, Android-specific APIs. With React Native, you're sort of dependent on the open source community, Facebook, or you wrap those components yourself, and you have to do your bridging yourself. So it's a little bit of at your own risk, but it is pretty straightforward. With Flutter, you know, they're going a quite different route. They're sort of like bypassing, they're like, forget about the native UI components. We're building UI components that look like the actual like iOS and Material UI components, but you're sort of at their mercy. They're not really letting you access you know, the iOS UI controls. You're on your own there.
So in a nutshell, we can say like none of them is quite there.
Yeah, definitely, there are challenges. Like if you wanted to access sensors, camera, and whatnot, it's less straightforward for you to go like implement that in Dart. So you have to go to pub, their like you know, repository, and find something that meets your goals, and that definitely introduces some dependency, and needs to be a consideration.
And one more question, like, is there any specific design pattern that you feel like is implemented now, either by Flutter or by the AppCode guys, to handle stuff when cross over the platforms, like simultaneously, or like they have something specific?
Yeah, that's a good question, and it's sort of like Google's approach. When you look at the Maps app on iOS and Android, they used to look similar for some time. They're sort of ignoring the fact that each platform has their own design language. So Flutter looks like we'll do that. It's sort of going to be implementing their own design language, and you'll be stuck with it. You're welcome.
Questions, and let's have one more round of applause for Korhan.